In this video, we will see the second quantum number, and that is azimuthal quantum number. This azimuthal quantum number is represented by small l. This quantum number is also called as subsidiary or secondary quantum number. Now, what this azimuthal quantum number gives you is the subshell to which the electron belongs. What are its allowed values? Its allowed values are from 0 to n minus 1. Let me explain what is the meaning of this. You know, students, that the principal quantum number value n can never be 0. So, if n is equal to 1, then the allowed values of L will be starting from 0, then n minus 1. So, it will be 1 minus 1, 0. So, the allowed values for azimuthal quantum number will be 0 here. Let us try one more. If n is equal to 2, then what are the allowed values of L? It will be 0. What is n minus 1? It will be 2 minus 1. So, it will be 1. So, I will start from 0 and then 1. So, when n is equal to 2, the allowed values of L will be only 0 and 1. Let us try n is equal to 3. What will be the allowed values of L now? It will be, what is n minus 1 here, students? It will be 3 minus 1, that is 2. So, I have to start from 0 and I have to go up to 2. So, it will be 0, 1 and 2. You can try this. N is equal to 4. Now, what are the allowed values of L here? What is n minus 1 here? N minus 1 here is 4 minus 1, that is 3. So, I will start from 0, 1, 2 and 3. So, when n is equal to 4, allowed values of azimuthal quantum number will be 0, 1, 2 and 3. Now, how to represent this 0, 1, 2, 3? There are some subshells, what it indicates. For that, let us see this now. If n is equal to 4, I will try for this now. Then what are the allowed values of L? If n is equal to 4, then the first value what I will have is 0. Second value will be 1. Next will be 2 and 3. Because I will start from 0 and I will go to n minus 1. N minus 1 will be 4 minus 1. So, I have to move up to 3. So, I got 0, 1, 2 and 3. Students, when L value is 0, this is the S subshell to which the electron belongs. If L is equal to 1, then it is P subshell. L is equal to 2, then it is D subshell. And L is equal to 3, then it is F subshell. Now, let us try for N is equal to 5. So, if n is equal to 5, then what will be the allowed value, student? Here n is equal to 5, n minus 1 will be 4. So, I will start from 0, 1, 2, 3 and 4. Now, for 0 it is S, 1 it is P, 2 it is D, 3 it is F, then 4 it will be after F we have G. We don't have this G in the periodic table. So, we have only S, P, D and F. So, this is how you calculate the values of azimuthal quantum number. Now, the question is how many electrons I can fill in this subshell for this main energy level. So, the rule which is used here is 2L plus 1. Now, how many electrons I can fill when L is equal to 0? Let me try for this, student. It will be 2 into 0 plus 1. So, it will be 2 and 1. So, how many electrons I can fill here in the S orbital or S subshell is only 2 electrons. Right, students? Let us come to this. It will be 2L plus 1 rule. So, this will become 1. 2 into 1 is 2 plus 1 is 3. So, how many electrons I can fill here is 6 electrons. So, when it is the P subshell, I can fill 6 electrons by using this formula. Let us try for this. It will be 2 into 2 plus 1. How much will be this? 4 plus 1 is 5. 5 2 times 10. So I can fill 10 electrons here in the D subshell. Similarly, for this, it will be 2 into how much, students? It will be 3, 7. So it will be 14 electrons. So in F subshell, I can fill 14 electrons. You can try this for your practice and comment the answer in the comment box. Now let us try one example for here how to write the azimuthal quantum number. So I am giving the chart in brief how to go for the azimuthal quantum number. So if n is equal to 1, as n cannot be 0, I am not starting with this. So what are the allowed values of L, student? This will be 0. Which subshell is this? Is S. How many electrons you can fill? 2 electrons. Right, students? Then N is equal to 2. Then what are the allowed values? Is 0 and 1. So what I can have here is S and I can have here P. So how many electrons? 2 electrons in the S subshell and 6 electrons in the P subshell. Let us come to n is equal to 3. What are the allowed values of azimuthal quantum number? 0, 1 and 2. So this will be S, P and D. Now how many electrons? 2 electrons, 6 electrons and how many electrons here? 10 electrons. Right, students? N is equal to 4. What are the allowed values? 0, 1, 2 and 3. So this is your S, this is your P, this is your D and this is your F. How many electrons? 2 electrons, 6 electrons, 10 electrons and 14 electrons. Let us see something interesting here, students. If I try to add this, see in the first n is equal to 1. How many electrons I am getting here? I am getting only 2 electrons. Right, students? If I come to n is equal to 2, it contains S and P. So how many electrons here? Is 8 electrons. See this now. This is the n is equal to 3. So what I have? 2 plus 6 plus 10. This will come to 18 electrons. What do you think this total must be? Must be 32 electrons. So if you see this, the splitting is taking in this place. So what you will have here is 1s. So my first orbital will be 1s. Next will be 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d and 4f. If you see here, there is no 1p, there is no 2d, there is no 3f. So this is what you have to remember. Thank you, students.